Mr. Bowman here. Today's learning objective is in blue. We are learning to factorize double brackets, but we're going to have a specific focus on perfect squares and the difference between two squares. So let's start off with an expanding reminder. So I'm going to call them PS, perfect squares, and an example would be x plus 3 squared. When you put that as a double bracket, it's going to be x plus 3 and then x plus 3 again, and then when we expand that, x squared plus 3x plus 3x plus 9, and then that there would come to x squared plus 3, plus 6x plus 9. So hopefully that rings a bell. That's what perfect squares are about. And then the second one we need to focus on is difference between two squares. And that was when it looked like this, x minus 4 and x plus 4. So we had plus and minus of the same number to do that. And then when we expanded that, we had x squared plus 4x minus 16, and that came to x squared minus 16. So that was a quick recap. Today we're going to learn how to factorize all of those. So let's change the pen color. We're into orange. Let's start off with the first type. So example 1, and we're going to focus on the perfect squares over here. So the one that comes to mind, let's say x squared minus 10x plus 25. And when we're dealing with a perfect square, it's almost the exact same procedure as we learned in our previous video. You've got to think what two numbers add to negative 10, but multiply to 25. You would write out all your factors like we did last time. So you would have 1 and 25, you'd have negative 1, negative 25, and you would have 5 and 5, and then negative 5 and negative 5. So they're all our factors. You then got to think which of them add together to get to that negative 10, and they'll be the ones at the bottom. So you'd start your working by go x minus 5, x minus 5, and then following that, you'd put that in the square form, x minus 5 squared. And that last one would be the factorized version of this perfect square. So let's have a look at another example. So example 2. So let's say we're dealing with x squared plus 18x plus 81. Same process. Which numbers add to positive 18? Multiply to 81. This time around, hopefully you're thinking 9 and 9. So we're going to go x plus 9, x plus 9. And when you put that in the perfect square form, you're going to have x plus 9 all squared. So these ones here, there's nothing really new to it. It's just a slight little twist to what we have been doing. We're going to change pen colors. We'll get into blue here. And we're now going to have a look at some more examples. This time they're going to be related to perfect squares. Let's have a look. Let's say you've got x squared minus 36. Whilst it's going to be very, very similar to the process we've learned in our previous one, the thing I want to emphasize, in the middle, there is technically plus 0x. So we need to think what two numbers add to 0 and multiply to negative 36. And if you go through your factors of 36, you should have negative 1 and 36, 1 and 36, negative 2 and 18, 2 and negative 18, and then we've got negative 3 and 12, 3 and 12, and should have negative 4 and 9, 4 and negative 9, and then 6 and negative 6. So you have your whole list of your factors, and the ones down the bottom will be plussing and minus the same number. So they're the letters, or they're the numbers that need to sit within our brackets. We're going to have minus 6 plus 6. And I just want to note, like any quadratic, it doesn't matter which way around your brackets are, you're still going to get to the right answer. So hopefully that makes sense. We'll have another look at another example. So example number 4. So let's say we've got x squared minus 100. Same thing. We've got to go through all our factors of 100, but we also need to figure out, well, which of them are going to add to 0? So what adds to 0x and multiplies to 100. And this time around, hopefully you're thinking 10 and negative 10. So you're going to have x minus 10, x minus or plus 10. So that was a pretty quick introduction for those first two, but I want to explore a little bit more detail about those perfect squares, and we'll use pen colors as well. So example number 5, or a different way to think about this type of question. So let's say you've got x squared minus 49. And what I want you to think about are these numbers here. So x is x times x, and 49 is 7 times 7. So when first and second part of a quadratic can be square rooted, they're going to be perfect with the difference between squares. So in our case, the square root of x is x times x, which is where we get our 2x's from. We then do the square root of the second part. In this case, square root of 49 is 7. So we're going to do 7 and 7. And because they're both squares, we're going to do plus and minus. And we can even do the same with more complicated ones. So if you have a look at example 6, let's say you got 4x squared minus 144. Same thing. If you square root the first part, and if you square root the second part, if you get a number, or you can simplify both of them, you're going to get to that. So if you think of 4x squared, the square root of 4 is 2. The square root of x squared is equal to x. So that's going to get us to 2x. And then the square root of 144 is 12. So when you set up your brackets, you're going to have 2x and 2x. And then you're going to have minus 12 and plus 12 as well. So a whole lots of different stuff for completing, or the difference between two squares. What I'm going to do is I'm going to pause. We're going to go through 2 or 3 really hard examples, the hardest ones I can think of, and then we'll have heaps of practice. So we're going to have a look at example number 7 now. Change pen color because they're going to be next level. So let's say we've got 81x squared minus 16y squared. So the first thing I've observed is there's 2 parts, and there's a minus sign. So that minus sign is really important. If they have both those criteria, there's 2 parts and there's a minus sign. If both parts are squares, you'll have a difference between 2 squares. So let's have a think about this first part. So the square root of 81, well, that's equal to 9, and the square root of x squared is equal to x. So that means that part there would come to 9x. We then can have a look at the second part. The square root of 16 is 4, and the square root of y squared is equal to y. So that comes to 4y. So what we've done is we confirm, well, both of them are actually squares because we can square root them. So we're then going to set up our brackets, and the first bit, which is the 9x, we're going to place that at the beginning of each bracket, 9x and then 9x, and then we're going to go 4y and 4y, which was the second part, and then we're going to go plus and minus. So they do look a bit messy, they do look really complicated, but if we follow these 3 rules, you can factorize some really tricky questions. So let's have a look at example number 8. So let's say we've got 100a squared b squared, and we're going to go minus 9. So this one looks a bit easier than the other one, but have a think about our list. There are 2 parts, so we're happy with that. They are separated by a minus sign, so we're happy with that. We've then just got to check, are they both square numbers? Let's have a look. The first one's really complicated. There's 3 parts. So the square root of 100 is equal to 10, so happy with that. Square root of a squared is equal to a, so happy with that. And square root of b squared is equal to b. So that there would have a square root of 10ab. And then the one at the end is a lot easier. Square root of 9, that's equal to 3. So we're going to have our last criteria of both being square parts. So when we do that, we set up our brackets, and this one's just going to be a bit cozy. We're going to have 10ab, 10ab. We're then going to go minus 3. We're then going to go plus 3 as well. And just like that, we factorise quite a complicated perfect square. And last question, example 9. So let's say we've got, what's a good example? Let's say we've got 36 x to the power 4, and we're subtracting 169 y to the power of 6. So the same process, we're going to be looking at, is everything square numbers? So yes, there's two parts. Yes, they're both separated by a minus sign. We've now got to check that they're squares. So the square root of 36 is 6, and the square root of x to the power 4, well, that's going to be x squared, because x squared times x squared equals x to the power of 4. We've then got to do the same for the last part. The square root of 169 is 13, and the square root of y to the power of 6 is y cubed. And that's because y cubed times y cubed is y to the power of 6. So that means we've confirmed the square root of that part is 6x squared, and the square root of this part is 13y cubed. We can then go ahead, set up our brackets. So we've got 6x squared and 6x squared as well. We're then going to go minus 13y cubed, and then we're going to go plus 13y cubed. And that there would be the double bracket for that difference between the squares examples. So hopefully you found this video useful. Some of it is really, really easy, and then we can see how much of a nightmare the ones at the end can be. So make sure you get all these notes down, all these examples down, and more importantly, once you finish that, let's get into heaps and heaps of practice. Thanks so much for watching, guys.